Right now, at this exact moment, a robot the size of a grand piano is racing through space at 32,000 miles per hour. It's so far away that sunlight, which takes 8 minutes to reach Earth, takes over 7 hours to reach it. And here's the mind-blowing part. This spacecraft has already completed its mission, but it refuses to die. And what it's discovering in the darkness beyond Pluto is rewriting everything we thought we knew about the edge of our solar system. By the end of this video, you'll understand exactly why New Horizons' journey through dying light might be the most important space mission you've never heard of, and why scientists are in a desperate race against time to extract its final secrets. Let me set the scene. When NASA launched New Horizons in 2006, they gave it one job: get to Pluto, snap some photos, and give us our first real look at the solar system's most mysterious world. It was the fastest spacecraft ever launched, reaching lunar orbit distance in just 9 hours. Apollo took 3 days. The spacecraft did its job perfectly in 2015. Remember those stunning images of Pluto's heart-shaped glacier? The nitrogen ice plains? The mountains made of frozen water, tall as the Rockies? Mission accomplished, right? Time to retire and drift into history. But here's where it gets weird. Instead of shutting down, New Horizons kept going. And now, nearly 5.5 billion miles from Earth, that's 58 times farther than the Sun, it's sending back data that has astronomers completely baffled. Because out there, in the cosmic darkness where sunlight is barely a whisper, the universe is glowing. And it's glowing way brighter than it should be. What's creating this light? Where's it coming from? And why does it threaten to overturn a century of astronomy? Stick with me. This gets wild. To understand what New Horizons discovered, you first need to know what this spacecraft actually is. Because unlike the rovers on Mars or the Hubble telescope, this thing was built for speed, not longevity. New Horizons weighs about 1,000 pounds. That's roughly the weight of a grand piano. But most of that weight is fuel and scientific instruments packed into a frame the size of a small car. It carries 7 scientific instruments. But here's the thing. It was never designed to operate for more than 15 years. The original plan was simple: 9.5-year journey to Pluto. Quick flyby. You can't orbit because you're moving too fast. Maybe a few years of extended mission, then silence. But NASA engineers, in a stroke of either brilliance or hubris, built in a contingency. Think about buying a car rated for 100,000 miles, but the manufacturer secretly over-engineers it to last 300,000. That's what NASA did with New Horizons, and thank God they did. After Pluto, NASA identified a second target, a tiny, frozen world called Arrokoth, shaped like a cosmic snowman. New Horizons flew past it on New Year's Day 2019. It's the most distant object ever visited by a spacecraft, 4 billion miles from the Sun. And that should have been it. Mission complete. Power down. Drift into legend. But one scientist had a different idea. Dr. Todd Lauer had been thinking about a problem that's haunted astronomers for decades. How bright is the universe, really? Not the stars we can see, not the galaxies we've cataloged, but the total light output of everything that exists. And here's the problem. You can't measure this from Earth. Our atmosphere scatters light. The sun blinds our instruments. Even in space telescopes like Hubble, there's zodiacal light, dust in our solar system reflecting sunlight, creating a constant background haze. It's like trying to see the stars from Times Square. The foreground lights drown out the background, but New Horizons was in the perfect position, far enough that zodiacal light fades to almost nothing, dark enough to see the universe's true brightness. So Lauer and his team proposed something audacious: turn New Horizons into the most distant light meter ever built. And in December 2020, they got their chance. Okay, imagine you're standing in the middle of the desert at midnight. You turn off your flashlight. It's dark, right? But not completely dark. There's starlight, moonlight, maybe some distant city glow on the horizon. Now imagine removing everything: the moon, the cities, the Milky Way, every visible star. What's left? That's what astronomers call the cosmic optical background, or COB. It's the ambient light of the universe itself, once you subtract all known sources. And measuring it is insanely difficult. The New Horizons team had to wait for perfect alignment. They needed the spacecraft pointed away from the sun, away from the galactic plane where most stars are, away from any planets or moons, during a period when all onboard LEDs could be shut off and when the instruments had enough power to spare. That perfect window? A few hours, once a year, maybe. It's like being a wildlife photographer trying to capture a rare bird. You have one chance when the light is right, the animal appears, and your camera actually works. Miss it, and you wait another year. New Horizons used its main camera, called LORI, the Long-Range Reconnaissance Imager, to capture images of 7 carefully selected patches of sky. Then came the tedious part. Scientists had to identify and subtract every single known light source from those images. Every star, subtracted. Every galaxy, identified and removed. Zodiacal light models, calculated and subtracted. Stray light from instruments, measured and removed. Cosmic rays hitting the detector, filtered out. This process took months. Lauer's team went through pixel by pixel, using data from other missions, galaxy catalogs, sophisticated models. And when they finally subtracted everything they could account for, there was still light. A lot of light. The cosmic optical background measured by New Horizons was about twice as bright as it should be. Let me put that in perspective. After accounting for every star in every galaxy we've ever observed, there's still enough mystery light to equal all of that again. It's like doing your taxes, adding up all your income, and discovering your bank account has twice as much money as you earned. Something's not adding up, and scientists have been scrambling to explain it ever since. But before I tell you the leading theories, and trust me, they get weird, you need to understand why this measurement is so revolutionary. For over a century, astronomers have been trying to count the universe. How many galaxies exist? How many stars? How much total light? Every new telescope brings us deeper views. Hubble, Spitzer, James Webb. Each one reveals galaxies we never knew existed. But here's the problem. There's a fundamental limit to what we can see. Some galaxies are just too faint for even our best telescopes to detect. They're called low-surface brightness galaxies, and they might be everywhere. Think of it like this. You're in an airplane at night, flying over rural countryside. You can see the bright cities easily. But individual farmhouse lights? They're too dim to spot individually. But collectively, all those farmhouses create a glow you can measure. That's what New Horizons might be seeing. The collective glow of countless ultra-faint galaxies we can't resolve individually. If the excess light comes from hidden galaxies, it means our models of galaxy formation are fundamentally incomplete. Current theory says galaxies formed in a specific way after the Big Bang. Gas collapsed into dark matter halos. Stars ignited. Galaxies merged and evolved. But if there are millions more dwarf galaxies than predicted, it means early star formation was far more widespread. Dark matter halos are more abundant than we thought. And the cosmic web of matter is denser than our models show. This affects everything, from dark energy calculations to predictions about the universe's expansion. It's like thinking you live in a town of 10,000 people, then discovering the actual population is 20,000. Everything about how that town works, traffic, resources, infrastructure, suddenly needs recalculating. But there's a second theory, and it's even more mind-bending. What if the excess light isn't from galaxies at all, but from stars that don't belong to any galaxy? When galaxies collide, it's not a gentle merger. Stars get ripped away by gravitational forces. Some get flung into the darkness between galaxies at incredible speeds. These intracluster stars, or orphan stars, become cosmic nomads. No galaxy to call home, just drifting through the void for billions of years. And here's the crazy part. Some estimates suggest that up to 50% of all stars in the universe might be these wanderers. Half of all stars, not in galaxies. If that's true, then we haven't been mapping the universe wrong. We've been fundamentally misunderstanding what the universe even is. We've always pictured the universe as galaxies, bright islands, separated by vast stretches of empty darkness. But if orphan stars create this much background light, the reality is completely different. The universe might be more like foam, or a web, where the space between galaxies is nearly as bright as the galaxies themselves, just spread out over much larger volumes. There is no empty space. It's all connected, all illuminated. And there's a third possibility, and it's the one that gets physicists really excited. What if the light New Horizons detected isn't from stars or galaxies at all? What if it's from dark matter? Dark matter makes up about 85% of all matter in the universe. We know it exists because of how it affects gravity. Galaxies rotate too fast to hold together with just visible matter. But we've never directly detected a dark matter particle. Ever. It doesn't emit light, doesn't absorb light, doesn't interact with normal matter except through gravity. It's been physics' greatest mystery for nearly 90 years. Imagine knowing your house is full of furniture because you keep bumping into things in the dark, but when you turn on the lights, nothing's there. You can feel it, measure its effects, but you can't see it. That's dark matter. But some theoretical physicists have proposed that dark matter might not be completely dark. What if dark matter particles are unstable? What if, very rarely, they decay, breaking down into lighter particles and releasing a tiny amount of energy? A single decay would be undetectable, but multiply it across the entire observable universe over billions of years and you get a faint, diffuse glow everywhere, all at once. And the amount of light New Horizons detected? It's consistent with certain dark matter decay models. If New Horizons actually detected dark matter decay, it would be the first time in human history we've observed dark matter doing anything other than pulling on things with gravity. It would confirm dark matter is made of particles, not just warped space-time. It would tell us those particles can decay. It would give us clues about their mass and properties. It would potentially identify what dark matter actually is. This would be Nobel Prize level physics, revolution level, textbook rewriting level. But here's the problem. We can't be sure it's dark matter. The signal could still be hidden galaxies, or orphan stars, or some combination of all three. To distinguish between these theories, we need more measurements, better measurements. Measurements from different angles, different positions in space. We need time, and that's the tragedy, because New Horizons is dying. Remember, New Horizons doesn't run on solar panels. Out there, the sun is just another bright star, too dim to power anything. Instead, the spacecraft carries a plutonium-238 power source. It's basically a nuclear battery that converts heat from radioactive decay directly into electricity. When New Horizons launched in 2006, this RTG produced about 202 watts of power. Today, 173 watts, and dropping. That's less than 2 old-school incandescent light bulbs. Imagine running a sophisticated scientific laboratory with cameras, computers, transmitters, guidance systems on the power it takes to light a small room, and it gets worse every year. Every system on New Horizons competes for that shrinking power supply. The transmitter needs 28 watts to send data across 5 billion miles. Guidance and control takes 30 watts to keep antennas pointed at Earth. Computers use 20 watts, 1990s-era processors running the show. Instruments are variable, but hungry for power, and heaters are critical as temperatures plunge to 300 degrees Celsius. The team has to make brutal choices. Every observation means shutting down something else. Every measurement is a trade-off. Dr. Alan Stern, the mission's principal investigator, describes the planning process like this. We get maybe 1 shot per year to do these cosmic background observations. We have to position the spacecraft perfectly, power down everything non-essential, and hope nothing goes wrong. They did measurements in 2020, 2021, 2023. They're planning observations for 2024, 2025, every year until the power runs out. Current projections say New Horizons can operate until the mid-2030s. Maybe 2035, maybe 2038 if they're lucky and ruthless about power management. But it won't be a sudden shutdown. It'll be gradual, agonizing. First, they'll lose the ability to run multiple instruments simultaneously. Then, the heaters will start failing. Instruments will freeze. Communication will become intermittent as the transmitter gets less power. Eventually, there won't be enough electricity to keep the computer running. And then, silence. But New Horizons won't stop. It'll keep drifting. Forever. It's moving at 31,000 miles per hour relative to the Sun. At that speed, it'll take about 40,000 years to reach the distance of the nearest star, long after human civilization has either spread to the stars or gone extinct. This little robot will still be out there. It carries a golden disc with images of Earth, music, greetings in 55 languages, like the Voyager Golden Records, but simplified. A message in a bottle, cast into an ocean so vast that the distance between Earth and Pluto is less than a single drop of water. Think about that. Something we built. Something we touched. Something that bears our names and our hopes, drifting in the darkness until the sun dies and the stars fade. Still chasing the dying light. So where does that leave us? We have three possible explanations for New Horizons' ghost light. Hidden galaxies. Millions of ultra-faint galaxies filling the early universe. Orphan stars, half of all stars drifting between galaxies. Or dark matter decay, our first direct detection of physics beyond the standard model. And right now we can't definitively choose between them. Scientists are planning follow-up observations. James Webb Space Telescope can search for those ultra-faint galaxies in deeper surveys. Proposed missions could send small probes even farther than New Horizons, specifically to measure cosmic backgrounds. Ground-based observations are trying to detect orphan stars in nearby galaxy clusters. But here's the truth. New Horizons is in a unique position. Nothing else we've built is that far out, in that quiet of a location, with functioning instruments. Every measurement it sends back is irreplaceable. So here's what we know. Somewhere beyond the edge of mapped space, a robot built for a 10-year mission is performing science it was never designed for. It's measuring light that shouldn't exist. That light is either revealing hidden galaxies, illuminating a cosmic web of orphan stars, or showing us dark matter for the first time in human history. And we have maybe 10-15 years to figure out which one before the power dies and silence falls. That's why New Horizons' journey through dying light isn't just important. It's potentially the key to understanding what the universe is actually made of. We built a spacecraft to see Pluto, but we accidentally built something far more profound. Humanity's most distant eyes staring into the darkness, measuring the light we can't explain. And every year that those eyes stay open is a gift. Sometimes the most profound discoveries happen at the edge of our reach, in the last moments before the light goes out.